Okay, so I'm recording another video. I'm gonna go over to my shortcut script, and let's see. Okay, and I'm just gonna make a note here. Tile internal coordinate x, and that's like that, yep. And then same thing for tile internal coordinate y, and tile internal coordinates y. Paste that. We might want something more general, so like tile internal and internal coordinate and internal tile, internal pixel internal. So I'm just trying to make up some keywords where, you know, if I forget that I created this variable, what are some like things that I might type to jog my memory? Local tile coordinate, local tile local, and maybe LTX, LTY for a local tile X, local tile Y, and I'll just say if pixel chord within a single tile, use then X, or actually it would be like X or Y, like that. And then for this prompt here that I'm creating, I'm gonna say so like if somebody types that, or they type that, or they type if they type one of these, then it's gonna correct the spelling. And then if they correct it, if they do it completely correct with no problems, I'm just gonna prompt. I'm not gonna hold on. I'm just gonna let them know that if they type it correctly, I'm gonna put a little check mark at the end to let them know that they typed it correctly. And then we'll take and I have mixed up my X's and Y's here, so that should be Y. Oh no, wait. No, that should still be X, but I need to indent here like that. And then we're gonna paste this here, and we'll make these Y's as for the Y version of the variable. And the next part was, well, what if they type this without anything? And so if they type that without anything, or maybe they type it like this because it kind of sounds like Tinko, pick, and then maybe we'll write it this way. Okay, so this, does that highlight? Yep, those highlight what I expect. So the tile internal coordinate, so this internal stuff, it's kind of the same thing as this prompt up here, but it's slightly different. I'm gonna put this up here and maybe see what the difference between tile internal. Okay, so this if I type this, I'm more certain of what it should be. So I'm just gonna say use and this dash X or Y. And then what I can also do is have a little note of what the Tinko stands for. Tile internal coordinate. So that means that this N needs to be capital like that. And I'm also going to take this here, and right down here I'm going to have like Tinko means, like that. Just have the definition. And we should probably also have the same thing for X and Y. So Tinko Y means and tinco y means, and tinco y means like that. And it's going to be the same thing, right? But it's just that it's for a specific axis. So tinco underscore y, and then we can do that. We can just put a y axis chord. So that chord, well, I guess it's more not a chord, but a coordinate would be two things. So really what I'm saying is it's the axis / component, right? It's the y component of that, and maybe I'll indent that since it's a more specific. And then over here we're gonna make this x, make that an x, make that an x, and make that an x. And okay, so that's all. That looks all good to me. So we've kind of documented what that variable name means, and yes, it does seem kind of overkill, but it's nice to have a variable that has an exact meaning that I can latch onto, because my logic kind of gets fuzzy when I start to not know what a variable exactly stands for. For example, used up pixels x and used up pixels y, like, I could come up with something a little bit better than that. But let's just keep on solving the formula. So the internal coordinates are going to be, so tinco x equals the number of tiles we've currently used, so tx, but remember the first tile starts at 0, so right, so the first tile doesn't use up any pixels. Oh, we already have the used up pixels. So what we could just do is you could take, since we can't figure out a good name for this, we could just take the used up pixels and we could put it here, and then we don't even have to think about what the name for that is, right? You know, maybe it would be best not to have a name for it. So we have our used up pixels, and then what we're going to do is we're going to subtract, hold on, dx, yeah, okay, yeah, so it's the other way around. We're going to take the dx and dy, so dx and dy, actually not the dx and dy, but the, because that's where the viewport is on the canvas, we want this local dx, local dy, we're going to take that, so local dy, right? Local dy is gonna be somewhere inside of the tile, but we want to subtract those used up pixels, which is the width of a single tile as seen on the destination viewport, multiplied by how many tiles in we currently are. And so if we do that, this should be the, oh wait, sorry, I'm mixing up my x's and y's here. And y, and then right, instead of width we use height. So, and we can, we're not really, it's kind of taking up a lot of room here. Dx, dy, tx, dy. Okay, yeah, so that, that should be what we need to get the local coordinates within a single tile. And because we have local coordinates inside that single tile, we're going to be better enabled to figure out how to draw a dashed border around every single tile. But before we do that, we could try to do a little overlay over each tile. Or we could try, what we could do is we could try to, like, black out all of the, black out or white out all of the odd tiles or something, you know, just to see if we get, like, a checker pattern to make sure that this actually covers the tile. There's a lot of things we could do to confirm that, these values are correct. Or, instead of wasting all that time, we could just go right in for the kill and do the calculations for figuring out the checkered border around the tile. I think I'm going to do a compromise, like a little hybrid of those two ideas. Like, I don't want to completely black out the tile. I'm not quite ready to figure out a checker pattern that's 1 pixel thick around the whole thing. But what I could do is, now that we have these local coordinates, we can figure out how far away a local coordinate is from the center of the current tile, and we can maybe draw the tile color darker if you're like on the border of the tile, right? So to give all of these colored pixels kind of like a intense, richer colored outline, or a darker colored outline around them, right? And this could be like a thicker border. We don't have to worry about if it's exactly 1 pixel thick. It's just something to test out our logic here. Before that, we're going to have to move in some of this code that we've been kind of scratch padding over here. We're going to have to move that over into the main formula code. And I'm not quite ready to do that. I mean, I want to take a break, I think, before I do this. Shouldn't be too hard. I mean, we do have some new variables. And so basically all we have to do right now is move over more of our calculations. And we don't even need this, right? We moved that. What we could do is we could make a little comment here. We can go like this: used up x, right? So instead of having a variable name, we can just have like a little note. So when I put a comment inlined in here between parentheses, it means that whatever this equation is doing, this is what it stands for, right? And so it's inside these parentheses, and that way if you took this chunk and moved it somewhere else, the comment would come along with it. And that's when I'm not like totally committed to the name for this, but I want something that's gonna kind of help give you a clue as to what this is. Okay, so I'm gonna stop recording just because I want to take a break and walk around and possibly reload my shortcuts since I typed all that stuff out, and then I'll be back and we'll get this integrated into the main code and see if we can get some colored outlines around each tile. And I'm also going to end the stream as well, just because I actually want an actual break, so there's no need to leave on the stream if I'm not actually doing anything.